Let's do some problems from work transfer. Here I am bringing some beautiful descriptive problems. Now some of you may be having a thinking that why we are doing descriptive problem in a GATE class, right? That's because these selected descriptive problems are meant to impart a lot of knowledge. Just by learning the concept will not make sure that our command over the subject is superb. By doing some quality problems that ensures our clarity or command of the subject is done. So for that purpose I have selected some very good problems. Let's do them. Ready? A spherical balloon of 1 meter diameter contains a gas at 150 kilopascal. The gas inside the balloon is heated until the pressure reaches 450 kilopascal. During the process of heating, the pressure of gas is proportional to cube of the diameter. Find the work done by the gas inside the balloon. Note that the process can be treated as a reversible process. Here I am having a balloon of 1 meter diameter and I am supplying heat to it. When I am supplying heat to the balloon, what will happen to the air or the gas inside the balloon? It will expand, right? And balloon material is a stretchable material. As a result, the balloon will expand. But it is not expanding freely, as in the case of a piston cylinder without any friction. The material is expanding, giving some restriction to the expansion. As a result, some pressure is being built inside the balloon than the previous value. At the same time, its diameter is also increasing. So in this question, initial diameter is 1 meter. By the end of heat transfer, its diameter is increased to some value and final pressure is 450 kilopascal. And it is also given that the pressure developed inside the balloon is proportional to cube of the diameter. Finally, they are telling us to find what is the work transfer involved in this process. Fine. Now, generally we are having some standard process, right? Constant pressure, constant volume, isothermal, adiabatic and so on. Did this process fall into any of these category? That's the first question we should ask. It is neither constant volume, nor constant pressure, nor isothermal, not adiabatic for sure. It is not any standard process. So how can we deal this process? How can we find the work transfer in this process? It is given that it is reversible process. So we can straight away go for W is equal to integral P dV for finding the expansion work. Because expansion is happening here, so it's a boundary work. So we can substitute values in that equation and we can find the answer. Fine. Fine. Let's start doing this problem. Here it is given P1 is 150 kilopascal, P2 is 450 kilopascal and D1 is 1 meter and D2 we don't know. Also given pressure is directly proportional to D cube. Fine. Now we know that for a reversible process, work transfer is equal to integral P dV from V1 to V2. This is the case. Now, do we have any values that we can directly substitute and get the answer? Let's see. Here it is given that pressure is directly proportional to D cube. From here I can write pressure is equal to K D cube, where K is proportionality constant. So this is a generic equation. This should be applicable for P1. I can write it as P1 is equal to K into D1 cube. It also should be equal to P2 into K into D2 cube. That's how this equation works. So now I got P is equal to KD cube. Alright. And by supplying by giving P1 is equal to K into D1 cube, I can get the value of K as P1 is nothing but 150, D1 is 1 meter. So I can get the value of K as 150 kilopascal per meter cube. Fine. So I got the K value. Why are we finding this value? Because we want pressure in some term. So I know that pressure can be expressed as 150 into D cube. Fine. Now I want to substitute this here. So I know that work transfer is equal to integral V1 to V2 150 D cube into dV. Fine. I am just substituting value of P here and equation becomes like this. Now I am having a question. what is integral x square dx? What is integral x square dx? You will say that it is nothing but x cube by 3 plus c. Correct. Now if I am asking the question, what is integral y square dx? Y is a variable. Can you do that integration? You cannot do that integration because you don't know how y is varying with respect to x. If they are given that y square is equal to x or y square is equal to x square, then I can substitute it as x square dx and I can do corresponding integration. What I meant to say is that in order to do this integration, you should be knowing how y is varying with respect to x or dx. If you know that, you can do that. Similarly, here, if you want to do this integration, you should know how d is changing with respect to dv. Now, pause the video, try doing this problem by yourself. Now, we know that volume, what is dv? dv is nothing but change in volume, right? We know that volume of sphere is nothing but 4 by 3 pi r cube. Instead of r, I am substituting d by 2 cube. Fine. This can be written as 4 by 3 into pi into d cube by 8. So 4 by 8 will be cancelled and I will be having 2 here. So I will be getting it as pi d cube by 6. Now I will take the partial differentiation. I will be getting it as dv is equal to pi by 6 into 3d square dd. So from here I can cancel this into 2. I will be getting dv is equal to pi d square by 2, pi d square by 2 into dd. Pi d square by 2 into dd. Correct? That's what dv value. Now I can put that value here. Instead of dv I can substitute this value. Instead of v1 to v2. Earlier the integration was for dv. Now the integration will become with respect to dd. So it should be from d1 to d2. If you can solve that, your answer is ready. Let's do that. So I got dv is equal to pi d square by 2 into dd. I will substitute this value to here. And I will be getting w as 150 d cube into pi d square by 2 into dd from integral d1 to d2. What is d1? d1 is something but 1 meter. What about d2? That we don't know. Say we will find that. Let's do this integration first. I will be getting 150 pi by 2 will be constant. I will be getting it outside 150 pi by 2. Here I am having d cube into d square, which is nothing but d raised to 5. So I will be having integral d raised to 5 into dd, that is nothing but d raised to 6 by 6. D raised to 6 by 6 from d1 to d2. I already know what is d1, which is nothing but 1 meter. How can I find d2? For finding d2, we are having p is equal to kd cube, right? So I can write p2 by p1 is equal to d2 by d1 whole cube. So p2 by p1 is equal to d2 by d1 whole cube. By solving this, I know p2, which is nothing but 450 kilopascal. P1 is nothing but 150 kilopascal. What is 450 by 150? 3. D1 is 1. So I will be getting 3 cube root of 3 is nothing but D2. Cube root of 3 is nothing but 1.442 meter. So I will be getting value of D2 as 1.442 meter. I will substitute that value here. So after substituting that, I will be getting the equation as 150 pi by 2 into 1 by 6 into 1.442 raised to 3 minus 1 cube. So after solving this, you will be getting the work transfer. Can you tell me the answer? It should be something around 310 kilojoule or 313 kilojoule.